I hope all of you are doing well. My name is Shriya Bansal and I'm currently working as a software engineer at Microsoft, and I'm also an educator at Re-Level. So let's quickly start without wasting any time with our very first discussion today, which is going to be on keys. So, like the definition says over here, keys play a very important part or very important role in the relational database. If you would have seen the videos for ER modeling, you would have seen that one of the major components for designing ER modeling is keys as well. Now, what are keys used for? Keys are basically used to identify a record, okay, or a row of data from the table. A record is nothing but a row in a specific table. Now, it is also used to establish and identify relationships between the tables. Now, a key can be a single attribute or a group of attributes as well, where the combination or the group of attributes may act as a key. So a few things to remember and quickly revisit over here would be that attribute. So attribute are nothing but characteristics of an entity. So when you have different entities, like we took the example of a school where the entity was class, student, teachers, subjects, right? Now, if I want to relate the entity teacher with the entity subject, I will have to use keys over here. That is why it also says that it is used to establish and identify relationship between the tables. Okay, and let's say I also gave you an example in the ER modeling session that if I have a set of students, right? If I have a big data set of students and there are many students in that, and if I want to uniquely identify a student, that will happen through key. And in that example, the student ID or a student roll number was the key, because student name cannot actually become a key for the very reason that name can be common for a lot of people. But key, or here the student roll number, is always going to be unique. Hence the student roll number can be considered as a key because it can be used to uniquely identify a particular student in a very large data set. Okay, so that's what it really means. Let's take an example here, and it's pretty much the same example itself. For example, ID, which is kind of like the student roll number, can be used as the key in the student table because it is unique for each and every student. So when you're in a class, you give unique IDs to each and every student, right? Roll number 1, roll number 2, roll number 3. No two students have the same roll number, right? No two students can have the roll number 5. Everyone will have a unique roll number. Correct? Roll number 1, roll number 2, roll number 3, and so on. Similarly, in the persons table, the passport number, right, the license number and the SSN, all are the keys, right, which can be used to uniquely identify a person. So remember, in a particular entity, right, or in a particular table, there can be more than one keys as well. Okay, so here in the student example, if you see, ID is the only unique key, individual single attribute which can be uniquely used to identify a student. But if the same thing you look at the persons table, in this there are multiple keys present. Passport number is also unique for everyone, so that we can use it to identify a person. The license number is also unique for everyone, so that also can be used to identify a person. Similarly, SSN, social security number, is also unique for each and every person, right, which can be used to identify a person. SSN we don't use in India. SSN is used in the United States to uniquely identify a person. The similar thing happens in India where we use Aadhaar number to uniquely identify a person. Okay, so remember, in the students table, we just have one primary key or one key over here, right, which is ID, which is used to identify a person. Whereas in the persons table, we can either use passport number, or we can use license number, or we can use SSN. All are keys which can be used to identify uniquely every person. Okay. Now, in the classification of keys also, right, there can be different types of keys which are present, which we are going to cover as well. So we have primary key, we have candidate key, we have super key, we have foreign key, we have alternate key, right? We have composite and artificial key. So there are a total classification of 7 keys which are present. And in this video, we are going to cover all of them. Remember, you have to remember the names of all the keys over here. To be honest, the names of the keys are very helpful because they actually kind of tell a lot on what the purpose of the key is going to be. Okay, so we are going to cover all of them in detail. Please make sure before we start to understand what are the types of keys present, you also understand why do we really need a key, right? What is the very purpose that we introduce keys in the very architecture for DBMS, right? So the idea is, in the real world applications that you will build, the number of tables that are actually required for storing the data is huge, right? As you will scale your applications and deal with a large of data, the number of tables will also increase and the data inside those tables will also be increased. And in most of the situations, many of these tables are actually related to one another. Okay. Now, the table's data actually extends to thousands, sometimes lakhs of values as well. And it's quite unorganized and it's quite, I would say, unsorted as well. So to fetch a particular data set, you want to know which particular row you need. And for that, you need to uniquely identify. So keys basically provide you that capability for searching and filtering through a very large, unsorted and unorganized data. Okay, because every time you store data, you don't store it in the most organized way, but you want to fetch, but whenever you are fetching the data, then you want to make sure that everything is being fetched in the most optimized way possible, and along with that, it's the correct row also that you are looking for. So keys are basically very helpful in that situation. Okay, all right, so let's start our discussion with the very first key over here, which will be primary key. Now the primary key is the first key used to identify one and only one instance of an entity uniquely. Okay, that means each and every record, each and every row will be uniquely identified, and that happens through primary key. Okay, an entity can contain multiple keys, right? As we saw already in the example of persons table. Any key that is used to identify a particular, I would say, entity uniquely can be considered as a primary key, and one table can have multiple primary keys or a single primary key as well, but every table will have a primary key. Okay, for example, in the students table, the ID was the primary key, right? But in the persons table, license number, passport number and SSN all were primary keys. Okay, the key which is most suitable from those lists basically become a primary key. Now there are 3 keys present, right? SSN, license number and passport number. All 3 are not primary key. Only one key becomes the primary key. So out of these 3, which is the one which looks more suitable to you, you can pick that particular key and that key becomes primary key. Think of it this way. In the students table, there was only one key and then hence it became the primary key. But in the students table, there was only one key, that is ID, and it became the primary key. But in the persons table, there were 3 candidates. Okay, think of it like candidate because it will help you later also. In the persons table, there were 3 keys, right, which were candidates to become primary key. Okay, and out of those, let's say I am working on a lot of data where passport number is very relevant, so it's more suitable for me, so I make passport number as the primary key. But there were 3 candidates to become primary key in that table. Okay, similarly, in the employee table, the ID can be the primary key. Every employee has a unique ID, right? So that ID can be the primary key since it is always unique for each and every employee. Whenever you join a company, you are given a unique, usually 6 or 7 digit or maybe 5 digit number. Okay, and that is unique for you. No other employee basically has that ID. And in the case, the ID can become the primary key. Let's say if I want to look at the details for a particular employee whose name is Aman. Now, just saying that I want to fetch details for Aman is not enough, because there can be a lot of Amans. But if I say, let's say I want to fetch the details for an employee number 60512, then I know that the person who has this ID is Aman, and then I will get all the details. Okay. Now in the employee table, we can also select license number and the passport number also as primary keys, since they are all unique. Okay. See, here in the employee table also, we are storing employee ID, we are storing employee name, employee address, passport number, license number and SSN. Now firstly, what are all the candidates to become the primary key? The candidates are employee ID, passport number, license number and SSN. Out of these candidates, you can pick any key to be primary key, and let's say I am picking employee ID. Okay, so that is what it says over here. In the employee table, the ID can be the primary key since it is unique for each and every employee. In the employee table, we can also select license number and passport number as primary keys as well, since they are also unique for each and every employees. Now for each entity, the primary key selection is based on requirements and developers, right? Out of the candidates that you have present, right? The one that you actually choose, right, for actually becoming a primary key, that can be based on your requirements and developers. There's no rule for that. I am using a table where, let's say, employee ID is of great purpose to me, right? Then I can choose employee ID. Okay. And if you feel that it's not very relevant, and for some other developer maybe passport number is more relevant, they can consider in their own database passport number as primary key as well. Okay. Again, it is based on your use case. So this is what is about primary keys. Let's talk about a new key now, which is candidate key. I think we kind of touched upon this a little bit in the last key as well. So a candidate key is an attribute or set of attributes that can be uniquely identify a tuple. A tuple is nothing but a particular row only. Okay. Now, except for the primary key, the remaining attributes are considered as candidate keys. The candidate keys are also as strong as the primary key. Now, if you take the example again for the employee part, you remember there were 4 keys: employee ID, passport number, license number and SSN. Okay. All the 4 keys were a possible candidate, right, to become a primary key, right? But out of these, let's say I only pick employee ID to become a primary key. Now the rest of the attributes or which did not become primary key will be considered as candidates key. Clear to everyone? That if I have 4 attributes which are candidates to become primary key, I pick the first one, rest 3 becomes the candidate keys. Okay, that is why you see in this example also that in the employee table, ID is best suited for the primary key, and the rest of the attributes like SSN, passport number, license number, all will be considered as candidate keys. Okay, and that's what pretty much the concept about candidate keys is. Now let's move on to our very third key. So we've covered 2, okay? Candidate key and primary key are pretty much related to each other. So you can club these 2 and then understand the topic. The third one that we have is the super key. Now a super key is an attribute set, okay? Remember, attribute set that can uniquely identify a tuple, okay? A super key is a superset of a candidate key, okay? Now here in a super key, we usually don't just take one attribute, we actually take a group of attributes to uniquely identify a particular record. For example, in the above employee table, employee ID and employee name, right? The name of the 2 employees can be same, but their employee ID obviously cannot be same. Hence, this combination can become a key, okay? Now the super key would be employee ID, employee name, etc. Now think of it this way. Sometimes what you do is, although here employee ID is present and it can use to identify, But the idea is sometimes you have a table in which no particular one single, I would say, attribute can use to uniquely identify a table. Okay, but it so happens that not just one but two attributes can actually be combined, and that can actually help to identify uniquely a tuple. See, if I just take employee name, now employee name is not enough to uniquely identify a particular employee. But the moment I club with employee ID, then both of them are enough to uniquely identify each and every employee. Let's say I go to a person and I say, what's your name? I want to look your details in the database. He or she says that I'm Aman. Okay. Now, Aman is not enough to uniquely identify a person, right? But let's say he also says that my employee ID is 65102. Now, with the name and the employee ID, now I can uniquely identify the employee which I am looking for. So sometimes a combination of attributes can be used to pick a particular key. Okay, and that is known as super key. Remember, a super key is always a superset of candidate key. Usually, you pick a few attributes from the candidate key, combine them and make it a super key. So that's why it says it's a superset. Okay. You can pick all the candidates key and you can pick some non-candidate keys also, combine them and make it a super key. In this example, employee ID was initially a candidate, right? And employee name is just a normal attribute. Combining both of them, taking a superset of it, basically makes up a super key. Okay? And that's what the concept for super keys is. Next, let's talk about what a foreign key is. Now, whenever we talk about foreign keys, they are the columns of the table that is used to point towards the primary key of another table. Now, make sure you understand this really well. There are two tables. One table has some columns, the other table also has some columns, okay? And one of those columns is nothing but an attribute, and that attribute is the primary key. Now, the foreign keys are the columns of a table that usually point towards the primary key of another table. Okay, every employee works in a specific department in a company, right? And employee and department are two different entities you see over here. Okay, employee, right? And every employee works in a department. So there's an employee table, okay, where we have the employee ID, we have the employee name, we have the employee passport number, we have the employee license number, we have the SSN, and we have the department ID. And here this is not employee, this is department table, okay. The next table is department table. Here this is the department table which has two, I would say, attributes, department ID and department name, okay. So here it says that every employee works in a specific department in a company, and employee and department are two different entities, correct? So we can't store the department's information in the employee table, correct? Because those two are entirely different entities. That's why, since we cannot store them together, we link the two tables through the primary keys of one of the table, okay? Here see, we basically added the primary key of the department table, which was the department ID, as a new attribute in the employee table. Okay, now see over here. I want to relate employee departments. Okay, I want to make sure that for every employee, I know the department in which they work in. So what did I do was, I had the employee table, I had the department table over here. Okay, now what did I do was, I basically used the primary key of the department table, okay, and basically linked it with the employee table. Okay, so what happened was, let's say this was the employee table. I took a similar example in the school and the subject part as well. Okay, let's say the department ID is 1, 2, 3, 4. Let's say business, finance, tech, and so on. And let's say here the employee ID is 65102, let's 720, let's say. Okay, then the name of the employee is Aman, right? Now if I want to link the employee with a department, I want to know this employee works in this department, so I will, with the few columns, I will also add department ID and I will mark it as 2. So that will help me to tell that Aman basically works in department number 2, which is finance. So this is how we have linked both the tables over here, and that is what it says as well. We add the primary key of the department table, which is department ID, as a new attribute in the employees table. Okay, and that's why we actually link the two tables through the primary key of the one table. So here we used the primary key of the department table to link employee and the department. Okay, you can see that in the employee table, department ID now is the foreign key and both the tables are related. Now this basically becomes foreign key. And now if you will go to the definition, right, department ID becomes the foreign key. And now if you will go to the definition, foreign keys are the columns of the table used to point to the primary key of another table, which is happening here as well. Foreign key, which is department ID, is the column of a table which is used to point towards the primary key of another table. Okay, and that's what foreign keys are. So foreign keys are a very good way to define relationship between tables and to link two tables. Now if I would not have done this, I would have to store all the details of all the departments in this table itself, in the employee table, which is redundant, which is not required. I ideally want to store both of these information in separate places. Okay, that's why employee and department table is different, and using a foreign key, right, which is a primary key for another table, I've linked both the tables. Okay, so that's how the concept of foreign keys work. Next we'll talk about the fifth key, which is the alternate key. Now there may be one or more attributes or a combination of attributes that uniquely identify each tuple in a relation. Relation is nothing but a table, right? And this we've already seen. Those attributes or the combination of the attributes are called candidate keys, correct? Now one key out of those candidates key is chosen as the primary key from these candidate keys, correct? That is what we've already seen. And the remaining candidate keys, right, if it exists, is termed as the alternate keys. Okay, now this is just I would say talking about terminologies. The concept is still the same. In other words, the total number of candidates keys, the total number of alternate keys is the total number of candidate keys minus the primary key, and the alternate key may or may not exist. Okay, if there is only one candidate key in a relation, it does not have an alternate key. Let's take an example. Now here, if you will see, let me give you an example itself for the students table, which we have already seen. So what all attribute it have? Student ID, student name, student age, address. Now here, what all keys are candidate keys? I can see that there is only one candidate key, which is ID, right? And since there is only one candidate to become a primary key, this one basically becomes the primary key itself, correct? And for this table, the primary key is the ID. Okay, now let's take another table, the persons table only, which we took earlier. The first is the person ID, person name, age, passport number, license number. Now first of all, what all are the candidate keys over here? ID can be a candidate key, passport number can be a primary candidate key, and license number can be a candidate key. Now out of these, I'll only pick one to become a primary key. So the primary key over here, let's say I pick the ID. So the primary key is ID. Now what all keys are left? Passport number and license number. So the leftover candidate key basically becomes alternate key, which is passport number and license number. Okay, so here you can see that since there was no more candidate keys left, so the alternate key here was 0. So that is why it says that for a table an alternate key may or may not exist. Right? But here, since there were multiple candidate keys, we had alternate keys left. That is why it says in the very definition as well that total number of alternate keys is the total number of candidate keys minus the primary key. And in a table or in a relation, right, the alternate key may or may not exist, like it did not exist in the students table. Now, if there is only one candidate key in a relation, that means it obviously means that you would not have an alternate key, because that single candidate key will become the primary key. Here the example is also given that the employee relations table has two attributes, employee ID and PAN number, right? That basically acts as the candidate keys, correct? Both employee ID and PAN number are candidate keys, right? Because both of them can individually identify an employee. Out of both of these, I pick employee ID as the primary key, right? Then what's the leftover attribute, right? That is PAN number, right? And that basically becomes the alternate key. Okay, so that is what is the formula over here. Candidate key is equal to primary key plus alternate keys. Perfect. Now let's move on to the last one, second last one, which is composite keys. Now whenever a primary key consists of more than one attribute, okay, it is known as composite keys, right? Sometimes the primary key cannot be just one single attribute. The primary key has to consist of more than one attributes, okay? Now this key is known as concatenated key, okay? For example, in the employee relations table, employee relations, we see that an employee may be assigned multiple roles, correct? And an employee can work on multiple projects also simultaneously. So the primary key will be composed of all the three attributes, the employee ID, employee role, and the project ID in combination. So these attributes acts as a composite key since the primary key comprised of more than one attribute. Okay, now the idea is, let's say you want to identify a particular employee, okay, who works on a particular project and has a particular role assigned to him or her. Okay, here what may happen is, let's say here, let me show you an example itself. I'm showing everything with data so that you can, draw good and meaningful relations. So here, let's say the employee ID, okay. Now here, let's say we have the project ID, right? Different projects are there. And let's say the employee role, the employee age, and so on. So and so on. So let's say there is an employee named Aman who has the ID 65720, right? And here the project ID for that is, let's say, 5. The employee role is, let's say, tech lead, okay, and the age is 32. Similarly, the same employee works on project 6 as well. Let's say he or she worked on a 6 as well. Here, let's say he was working as a staff engineer, and Aman only with 32. Okay, let's say he some other time worked on the project ID 13 also, right, where he was senior engineer, right, and this. Now let's say I want to uniquely identify a particular employee. Can I say the ID can be used for that? No, right? Because the ID is being repetitive. Why? Because an employee can take multiple roles, correct? Based on a project. So that is why here I can say the employee ID is not enough, correct? Similarly, we can say that instead of using employee ID, right? What we can do is we can use the ID, the project ID and the employee role. All three of them can actually be used, and then you will be able to identify the uniquely a employee. Here if someone says get me the employee 65720, that is not enough, right? Because there are so many same IDs, right? Now what do you really require? Now you also have to mention you require the ID, you require the project ID, right? And then you require the employee role as well. And then only you will be able to identify a unique row in this relation. Otherwise, you cannot do that. Similarly, simply on the project ID also, you won't be able to do that, because let's say there is some other employee also which work as a tech lead on this project. Correct? And simply just employee role is also not enough, because multiple employees work on the same role. But when you combine all these three together, then you can very well uniquely identify a particular employee. So the combination of all these keys basically becomes primary key. Okay, and that is what we say is the situation where multiple attributes combine to form a primary key to uniquely identify a relation. That is what a composite key is. Okay, now here that is why you can see that in this relations we can see that employee can be in multiple roles and it can work on multiple projects simultaneously. So the primary key will be composed of employee ID, employee role and project ID in combinations. So these attributes acts as a composite key, since the primary key is not single attribute. So remember over here, primary key, if it's single attribute, then it's just primary key. But if the primary key has multiple attribute, it gets converted into a composite key. It's still primary key, just the name that you're using is different. And now with this, the last one that we will talk about is the artificial key. Now the keys created using arbitrarily assigned data are known as artificial keys. These keys are created when a primary key is large and complex and has no relationship with many other relations. Sometimes in a table you pick a primary key, right, which has literally no relationship with other table. Okay, it is not being used as a foreign key in other tables. The data value of the artificial keys are usually numbered in a serial order. Okay. For example, the primary key, which is composed of, in the previous example, employee ID, employee role and project ID is large in employee relations. Okay. So it would be better to add a virtual attribute to identify each tuple in the row uniquely. Sometimes what happens is like not even 3 attributes are enough to pick a primary key. Sometimes you have to pick 4 or 5 attributes, right, for them to become a primary key, which is nothing but a composite key only, right? But sometimes you can pick 4 and 5 attribute, but it actually becomes very difficult to analyze this data and work with this. So what we do is, in situations like these, just a second. So what we do is, in situations like these, we actually add a virtual column on our own, let's say, which is row ID 1, 2, 3. It's just like a serial number, which helps to uniquely identify a row. So what you do is, initially you start with the primary key only, take these 2 attributes, uniquely identify the row which you require. Uniquely identify the row which you require, but for future purpose you simply just use this row number, because now that you have identified a row, you don't need to keep track of all of these attributes again and again. You can simply use the row number. Okay, and that is what it says over here. But artificial key is not really a particular attribute. Okay, these are arbitrarily assigned data to the particular relation that you have. Okay, and it is basically, you can see here, the row ID is nothing but a virtual attribute that is added to uniquely identify each tuple in the relation. Okay, and remember also, whatever artificial keys we pick up, they are usually ordered in serial number. Here you can see we start with 1, 2, 3, 4, and so on we go. So usually that's the good way to go ahead and pick up artificial keys. So it's only used when the overall use case becomes a little bit complex, right? And you don't have like a lot of it becomes very complex to keep track of the primary keys and the composite key. So you just introduce an extra column, right? Just 2 serial numbers, and it becomes a lot easier to do this. And trust me, you might feel that artificial keys is not used very frequently, but it's actually the opposite. Artificial keys are actually used very popularly, and they are quite useful as well. Alright, so this actually concludes our discussion on keys. I really hope you understand all what we discussed. To summarize what we all did today in this video is that we first identified what keys are, which are used to identify a particular key, right, or a particular relation or a record in a table or a relation, right? And then we talked about why do we really need keys, right? What is the purpose of introducing keys? And then we followed our discussion to introduce 7 type of keys which are there. We started our discussion with primary keys, which are used to uniquely identify a particular, I would say, record, right? Then we started with candidate keys. So usually we have multiple candidate keys and we pick one of them to become the primary key. And using that, you remember alternate keys. So club, primary, alternate, and candidate key. Candidate key is equal to alternate key plus primary key. Whatever keys do not become primary keys, they become alternate keys. Okay. Then we talked about, I think the concept over here for super key, which is the 4th key, right? In the super keys, what happens is that we combine some candidate keys and some non-candidate keys and make a I would say a way to uniquely identify each and every row. So here you can see that we combined employee name and employee ID, one candidate key, one non-candidate key, to basically uniquely identify a tuple. Okay, then we talked about foreign key, where we took a beautiful example of employee and department, where the primary key of one table is used in another table as well to draw relationships. That is what a foreign key is, and that was our 5th key. Alternate key we've already talked about. Then we talked about composite keys, where one key or one single attribute is not enough to uniquely identify a tuple. So we usually use 2-3 keys and make them and use them together to make it a primary key. Okay. And the last one is artificial key, where we have so much complex relationships and so complex primary keys that we introduce just one more column, which is just serial numbers for uniquely identification, which is a lot easier. Okay. Now what I would recommend is, don't just mix understanding all the keys together. That's when the real confusion happens. Keep all of them different. Do not mix all the keys together and their understanding. Make sure you learn it differently only, and understand the overall aspect. Okay. So make sure after this video you take some examples on your own and then try to identify. Take a student example, take an employee example, take a normal organization or a society example, take a hospital example, right? All these examples, and then try to identify all the 7 keys. Okay. But I hope I was able to help you in this a little bit, make this a little bit easier for you to understand by introducing a lot of examples, right? Thank you so much for attending this video now, and I will definitely move you and meet you in the next segment. Thank you.